I'll be going through Pei Chun P4 end of year paper. This paper is written in 2023. So question 29, fill in the blank with the tables with the name of the broad groups of living things. Dry skin with scales, it will be a key characteristics of reptiles. Okay, reptiles. That will be the key group that we will group them in. Body covered with feathers. Okay, feathers, it must be bird. For feathers, it must be bird. So the diagram shows the human digestive system. Put a tick to show where the large intestine is. Large intestine is actually this part. This part over here. So the arrow indicator will be this part. So this part will be the answer. Okay. The other part, this over here will be your mouth. This part is your gullet. This part is your small intestine. Okay, fill in the blank with the following helping word. Food from the gullet is next passed to the stomach. Okay, it will be stomach because the gullet here next it will go to this part. This part will be the stomach. Classify the following animals according to the number of stages in their life cycle. So grasshopper is 3, frog is 3, beetle is 4, chicken is 4. So the one with 3 stages will be your grasshopper, frog, and chicken. Okay, 4th stage will be your beetle. Okay. The diagram below shows the stage in the life cycle of a butterfly. What is Q? So this is your egg, larva, pupa, followed by adult. Okay, this is pupa over here. Okay. Li use an instrument to measure the temperature of the water. What is this instrument? This instrument over here will be your thermometer. Okay, thermometer. Okay, the temperature of the water in the beaker. So this one you might have to zoom in a little bit. Okay, 41, 42, 43, 44. Usually this long one that's a little bit coming out will be your 45, the halfway mark of 10. 46, 47, 48. Okay, this is 48 degrees Celsius. Okay, so the unit has been placed for you, so you don't have to put it. But if some school paper they don't write unit, so you have to put the unit on your own. Fill in the blank using the correct words in the box. So solid, liquid, or gas. So the beaker of water is placed in the freezer. After some time, the liquid, this one must be in a liquid state. The liquid will change state to become solid. Okay? When you put it in the freezer, it will lose heat and freeze into solid. Charlotte want to find out if the amount of water added to the slice of bread will affect the growth of mold. So over here, clearly we have the change variable, how it affects the growth of mold. Usually after the word affect will be your measured variable. This is your change variable, which is your cost, and this is your effect. Okay, she conduct an experiment with 4 slices of bread. She dripped different amount of water on 3 slices and keep the slice of bread in different part of the classroom. So one of them, she never add water. Okay. After 5 days, she observed and measured the amount of mold growing on each slice of bread. This is the result. So as you can see, when she added more water, the area of the mold patch actually increases. So based on the result, what can Charlotte conclude about the relationship? So this is a relationship question. Okay. So usually the relationship usually when writing a relationship question, we will say as the change variable increase or decrease, the measured variable could increase, decrease, or remain the same. Okay, this could be the possible scenarios. But over here, it is likely that the change variable increases, the measured variable also increases. Okay, the change variable is here, the measured variable is here. So based on the result, what can Charlotte conclude about the relationship between the amount of water added and the growth of bread mold? Okay, so this will be as the amount of water added increases the growth of the bread mold increases. Okay. Okay, so this part you can copy directly from the question, and it should be copied directly from question, but you need to know where to copy. This part will be this, and this part will be this. Okay, this part is related to this. This part is related to this, the area of the mole patch. Okay, so to conduct the experiment correctly, which of the following conditions should be changed or remain constant? The type of bread definitely must be the same. Okay, the amount of water must be the change because this is your change variable. Okay. Okay, we have a flowchart over here. We have different questions. Give birth to lie young, has a shell, has more than 2 legs. Based on the flowchart, state 2 characteristics of Y. So Y is over here. So they look. These are the questions that lead to Y. These are the questions. So which is this, and this. Okay, and this is no. This is no. This is yes. Has more than 2 legs. Okay, so what are the characteristics? So for Y, you could say it does not give birth to young. That will be 1. Number 2, you can say has no shell. Number 3, you can say has more than 2 legs. Okay, so this is given. Okay, so all these are taken out from the flowchart itself, directly from the flowchart. Based on the chart, state 2 differences between X and Z. X and Z is this part over here. Let me erase all the highlighted. Okay, X and Z, X and Z. So they are met with this question as well as this question. So these are the things that you can look at it. So you can say X has a shell, but Z don't have. Okay, so that will be one of them. X has a shell, but animal Z does not have a shell. It should be 1. This one I think it should be 1 differences. Okay, this one should be 1 because over here is 1 mark. So probably key wrong. Probably the questions are probably keying wrongly. Okay, X has a shell, but animal Z does not have a shell. Okay, letters W, X, Y, Z represent 4 animals. Okay, so this one it has a shell. Okay, then we got to look at it. Does it give birth to lie young? No, definitely no, and it has a shell. So the first animal should be X. Okay, so what about the second animal? Okay, which is it looks like a horse to me. Give birth to live young? Yes, because this is a mammal. Okay, the horse itself is a mammal. It gave birth to live young, so this one should be W. Okay, so it should be X and W. Okay, let's move on to the next portion. So Steve used the setup below to compare 3 different materials, PQR. Pour 300 ml of water onto each material and measure the volume of water collected in the beaker. So the measurement, right, is taken when the water enter into the container. So over here, which property of the material was tested in this experiment? The property is tested is got to do with something with water. Okay, and it should be either at waterproofness or absorbency. Okay, waterproofness or absorbency. Okay, that means whether it absorbs water or not, or if it absorbs water, how well it absorbs water. Okay, how much water it can absorb. Okay, so it should be this. Okay, so either one of them will be fine. Waterproofness or absorbency of the material, or you can say to find out which material are waterproof. So for part B, Steve set up a tent and secure it to the ground using strings, and we have the tent itself. That is something that we want to take note of. Okay, and which material will be the most suitable to make the tent? It will be P. Okay, because the amount of water collected in the container is 0, so it shows that no water enter the container. So most of the water are found here. Okay, it's being more or less trapped by the material. So it tells you that P must be waterproof. So I made the choice. It is waterproof, and it's because it is waterproof. Okay, why do I want it to be waterproof? Okay, for the chosen material to be the tent, is because the tent itself must be waterproof so that the water will not leak into the tent area, and then it will keep the user dry. Okay, the string is tied to the nail must be strong. So state what strength means. Okay, strength is a property that we can test for a particular material. And how do you test? You test by looking at the ability of the material to withstand load without breaking. Okay, there's a difference between strength and flexibility. For flexibility is the ability to bend without breaking. Okay, so usually we will say for flexibility we'll test how much it can bend before it breaks. Okay, for strength we will say test until it breaks. Test until it breaks. This one is how much it can bend before breaking. Okay, this part is crucial. It's key. Okay, still hold the tent as shown. Okay, and it show that it can be folded. What property of the tent allow it to be folded? The tent is flexible. Okay, the tent being flexible, we can fold them. Okay, wing, stroke, and iron bar in the same direction using the bar magnet as shown. Okay, he observed that the magnetized iron bar was able to attract a field. Okay, so when he do more stroke in the above direction, what will he likely see? Okay, there's this part of observation. What he will see about the number of pins, okay, that was attracted to the iron bar. So over here, he will see more pins that get attracted to the bar. And why? Over here, this is the explanation. Because the iron bar becomes stronger magnet. Okay, first of all, there is an element of more. Okay, more pins being attracted. Okay, and that's because the magnet itself becomes stronger. Okay, Wing placed the bar magnet next to an object as shown. Okay, he observed that the bar magnet was attracted. Okay, there was some attraction over here. Based on his observation, Wing cannot conclude whether the object is magnet or not. We are trying to conclude this. Okay, whether is it a magnet. Okay, using only the bar magnet and object, what should Wing do to conclude whether the object is a magnet or not? Okay, so what should we do in this scenario to prove that this object is indeed a magnet? Okay, so first of all, we have to show repulsion. Okay, because only magnet can repel one another. Okay, so the key is to find out whether they repel or not. So you notice that Y is here, right? So you just flip the other side and then check for repulsion. So this is how you can write it. You notice that there's letter assigned to here, right? Use the letters. Okay, these are letters for you to use. Okay, place NX to NP. Okay? So some of you may say flip the bar magnet around such that NX is touching NP is also fine. Okay? Then you can say if the bar magnet and the object repel each other, then the object is a magnet. If they don't, it is not a magnet. Okay? If it still continue to attract, right? If object attract the bar magnet, no, if the bar magnet attract object, then the object is a magnetic material. Because both ends attract, it shows that there is no pole. Okay? An object that was attracted to both sides, right, is not a magnet. It's most likely is a magnetic material because it got no pole to begin with as well. Okay, Xiao Lan planted a plant in her garden. Then you got leaf R. Okay, other than taking in water and mineral salts, what is the another function of the roots? Okay, the roots anchor the plant to the soil. Okay, this part anchor. Okay. Oh, actually, I mean anchor the plant firmly to the soil. Okay, firmly to the soil. Name the part of the plant that can hold the plant upright. That will be the stem. Okay. Okay. Xiao Lan wanted to group the leaf accordingly to their ages. Which leaf can be grouped together with leaf R? So we take a look at the edges. It's rather curvy, so we must find something that is very curvy. Okay, it looks like this is more or less very curvy. This one is very jagged. Okay, probably not this. This one is of a different shape, a little bit slightly jagged, but not as jagged as compared to the first one. Okay, so this one must be the one that can be grouped together. They have common characteristics. The side of the leaf is curvy, so they can be grouped together. Okay. Okay. Gary planted a seed and watched it grow. Draw the life cycle of a plant in the space below. Use only arrows and words. Okay. So first of all, this one will be the best. The best way to do it is to draw this. Is to start off with seeds. Okay. And then you go on to young plant, and then adult plant, and then you go back to seed. And remember the arrows or the way the arrow is being drawn is very important. Okay. Okay. In an experiment, Gary wanted to know how fertilizer L affect the growth of the adult plant. Okay. Then you take a look at this graph. This is the one with all the L. Okay. It seems like the one with all the L, right, is growing a lot more faster than the one without L. So what can Gary conclude about the effect of L on plant growth? L makes the plant grow faster. Okay, that will be one of the conclusions that it can make because the height of the plant is higher as the weeks goes by. Okay, so help grow faster. Okay, this part. Okay, so over here, Rashid used a glass jar as a coin bank. So describe one way to find this volume. Okay, okay. That means I want to find out how much space the glass jar occupies. Okay, first of all, I'll just pour in water. Okay, pour in water until it is full. Okay, then next I take all the water, I put it into a measuring cylinder. Okay, measuring. Okay, the equipment to measure water, to measure the volume of water accurately will be your measuring cylinder. This will be the only item you will use to measure the volume of water. Okay, why we need to use water? Because it is the item that is most easily found, and it is most importantly, it is a liquid. So it can take up the shape of whatever container you place in. Okay, so step one, fill the water into the glass jar until it is full. Okay, full, this part is important. Okay, next up, you pour the water from the jar into the measuring cylinder to find out the volume of the glass jar. Okay, the key portion right will be water until it is full. Put it into the measuring cylinder, and then you will be able to find the volume. Okay, the volume inside the glass jar is 100. So if he has 100 similar coin, each of them costs 100 centimeter cube. Why he cannot put all the 100 coins into the glass jar? This is because, right, when you place them into the glass jar, right, the coin cannot fit them nicely because the coin, remember, it is a solid. It has a definite shape. Okay, for this kind of question, you have to use the property of metal. What does property of metal means? Definite shape, definite volume. Whether is it solid, liquid, or gas. Then use the property to explain it. Okay, that will be one part. So coins, they are solids. They have a definite shape. Okay, and because of this, there will be airspace between each coin, which also occupies space. The coin cannot fit into the jar nicely, so the air spaces inside will disallow all the remaining coin to fit in. Okay, Rashi have a bin balance as shown, so we have hand A, hand B. He placed some coin on A, place a glass jar on B of the bin balance. He concluded that this has greater mass. Okay, if the glass jar has a greater mass as compared to the few coins, therefore what you will see, right, is that this one will go down and this one will go up. The one that has went down is heavier. The one that has went up is lighter. So that will be lighter will means that it has less mass. The one that is heavier, it means that it has more mass. Okay, so hand B will move down. This is the observation. It's just a observation question. You don't have to explain. Just tell me what you will see. Okay. So CND plays a setup below to find how much light can pass through different material. Okay. So you have S, R, and Q, which is the front view of the object, and you have the torchlight shining the object, and then you have the screen over here. Simply shone the light at the object. The diagram below shows the shadow form on the screen. Okay, so they tell you that this is light shadow, the bright patch of light, which is S over here, and R has a very dark shadow. So it seems that R is the one that blocks the most light, and bright patch of light, it seems like it blocked, or at least it didn't block any light at all. Okay, block the least light. Okay, this is one part that you can think of. Okay, so a light sensor was used to measure the amount of light that passes through each of the material. So match Q, R, and S to the correct amount of light. Okay, in the table below. So first of all, the one that is 0 and the one that is 500 is most easier to match. Okay, the one that is 0, right, will be it will match the darkest shadow. Okay, the one that is highest number will match S, because it has a bright patch of light on the screen itself. Okay, then Q will be the one that is in the middle. So which of the material could be wood or clear plastic? So these are the two extreme ends. Okay, so you choose something like this and this. You will not even touch Q. Okay, because over here wood is okay, right? It's most likely linked to R. Clear plastics will probably more or less allow all light to pass through, or most light to pass through. So that will be linked to S over here. That will link to S. Okay, so we'll state a property that enable the shadow to be formed. This one is light travel in a straight line. Okay. The reason why is this property is because, right, this main idea is because light, they cannot bend, they travel in a straight line. So whatever object that is placed in front of it, they will just hit it. And then if it's opaque, then no light will be behind. Okay? Because if it's opaque, this will block it. Okay? And this is the reason why you can see shadow. Because shadow is an area of darkness. Okay? Okay? So imagine if light is not traveling in a straight line, right? Then you totally will not see shadow or darkness. Because it will always, imagine this object, the light from the torch will always shine, then go behind. Then it will appear on the screen. Okay? Or go at the side, it will curve. Okay? Which is not the case. Okay? So therefore, this property over here is light travel in a straight line. Because light travel in a straight line, it can be blocked. Okay, it can be blocked by whatever object that is in the path of it. Therefore, you can see a shadow. Okay, Xianli would like to obtain a bigger shadow, okay, larger shadow, using the same item in the setup. Suggest one way, just is a suggestion to obtain a bigger shadow. Okay, so the one way to do it, right, is to draw lines. If exam you're not sure, right, you can draw line. So you put this start from here. Okay, this is the shadow that you will see. Okay, if this object is here. So if I move this object nearer, okay, sometimes you're not sure whether is it nearer or further, right? If I move the object nearer, same height, right? Same height. Okay, try to make it same height. Exam, if you have paper, you can use ruler. They'll be much clearer. So I'll use blue color. Can you see? The shadow over here is much larger. Okay. This is the one when I move the object nearer to the torch. Okay, you must say nearer to where? Because if you don't say nearer to where or to what object, then it could be nearer to the screen. Okay, then I have to guess. From there, if I have to guess, then it will probably not correct. Okay. So or you can say move the torch nearer to the object. Okay, either will be fine. Okay. So over here, it could be, there will be a few answers. Okay, number one, move the object nearer to the light source. Okay. Alternative answer you can consider is this. Okay, move the torch nearer to the object. Okay, it means the same thing. You're just trying to close the distance. Okay, so either of these answer will be right. Okay, so Sam conduct experiment using two identical flasks filled with water as shown below. So setup E has water, setup F also has water, but it's contained with bubble wrap, and this bubble wrap inside has air. The air is a key player. Okay, so over here I'll annotate this one with air, this one got no air or no bubble wrap. Okay, so Sam left both flasks in the room and record the temperature of water in both flasks over a period of time. Okay, what can he conclude about the bubble wrap? What can he say? Okay, so if you look at it, like if I would look at it at 10 minutes, okay, this is the amount of temperature increased by F. This is the amount of temperature increased by E. Okay, can you see that the water in the flask F actually increase slower but this one increase faster. Okay, so over here is trying to show one thing. It's trying to say that the bubble wrap is doing this, increasing the temperature of the water at a slower rate. The water is gaining heat from the surrounding, but it's actually gaining heat slower. It's because it's due to the bubble wrap. Okay, so the water has a lower temperature than the surrounding, so it will naturally gain heat from the surrounding. So imagine this has 4 arrows going through. Maybe this will have 6. This arrow represents heat from the surrounding that is entering to the flask of water. So I could have more. Okay. So over here, what kind of property does air has? It is trying to be or at least not that it's trying to be. It is a poor conductor of heat. It is. That's why it can slow down the heat gain. Okay. From by the water from the surrounding. Okay, so this is how I would answer this. Okay, the claim or the conclusion. What can we say about the bubble wrap? Basically, asking you this: the air is a poor conductor of heat. You cannot just say bubble wrap, because the main character or main key layer over here is not about the bubble wrap. It's about the air inside the bubble wrap being a poor conductor of heat. Okay, so and then how I know is because the temperature. Okay, temperature of water in flask F increase slower as compared to E. E increase slower, this part. And therefore, the water in flask F, not F, but the water inside gain heat slower from the surrounding through the air in the bubble wrap. Okay. Therefore, it will help us to support the idea that air itself is a poor conductor of heat. Estimate the temperature of the room. Okay, the temperature of the room, right, will be somewhere around here. Okay, because it will gain heat until it remains the same temperature as the surrounding. So this part over here is 30 degrees. How I know? I match it to this line. Okay, so I match. I know it should be the other way. I match it to this, so I know it's 30. Okay, so same thing. Unit has been written for you, so just have to plug in the numbers. Sam has a jacket made of material W. The material W has more air spaces in it. Okay, it's trying to tell you air W has a lot of air spaces in it. Okay, based on the result, explain how the air spaces in W will keep him warm when he wear the jacket. So the key focus is him, or rather Sam itself. How does air inside the material W help him to keep him warm? Because in a cold weather, this person will lose heat to the surrounding. Okay, in this case. But if you wear the jacket with material W, then you will have lose heat slower. Notice this one only got 2 arrows, this one got 4 arrows. Okay, so this person is wearing material W. Material W with a lot of air spaces. Okay, so this is how I will answer it. I will just say air is a poor conductor of heat, so the air will slow down heat loss from the person to the cold surrounding. Okay, the person is losing heat, that's why it slow down heat loss. Okay, if it's in the hot area, then he will be slow down heat gain, depending on the scenario of the question. Okay, so with that, we more or less have come to the end of this paper. Thank